Okay, so in this example we're going to figure out the definition of inverse sine. But before we do that, let's refresh our memory from algebra about inverse functions. If a function has an inverse, it's got to be 1-to-1. Why? Because if we have two x values, for example, a parabola, these two x values, they're different x values, but they produce the same y value. So no matter if I plug these two x values into my function, I get the same y value. When I come back, if I plug this y value into my inverse, what answer should come out? x1 or x2? We don't know because they're the same when we plug it into f. That's the problem. That's why we need it to be 1-to-1. So when for every 1 point here it goes to 1 here, then when I come back I'm going to know exactly which x value it goes back to. So here this is not 1-to-1 because it doesn't pass the horizontal line test. But we can make this sine graph 1-to-1 if we only consider this part of the graph. The part where x goes from minus pi over 2 to pi over 2. That passes the horizontal line test, and that is 1-to-1. So the definition of y equals the inverse sine of x, this is the notation. If I take the sine of both sides, I get the sine of y is equal to the sine of inverse sine x, but back in algebra we know f of f inverse of x is just x. So this is the same thing as this. They mean the same thing. But when I take the sine of y, the argument here has to be between minus pi over 2 and pi over 2 in order to remain 1-to-1. So that's why we have this restriction when we do work with the inverse sine function.